In this video lecture, I'd like to compare and contrast a population statistic versus a sample statistic. So if we go back to the initial sample where we had a population, i.e. all the males in the city of London, and we had sampled 30 males and computed a sample mean and a sample standard deviation. The sample mean was computed as the sum of the heights of every male in our sample divided by n, and the sample standard deviation was calculated as the sum of all the deviances, so xi minus x bar squared divided by n minus 1, and we had taken the square root of all of this. Now, if we wanted to find the population mean which is denoted by the Greek letter mu, will be the sum of all the people in your population, in our case, the city of London, and that is indexed from the first male all the way up to the capital Nth, if the size of the population is of size n, and naturally would divide that by capital N. The population standard deviation, which is denoted by the Greek letter sigma, is given as a sum of all the deviances. So how much a person's height deviates from the population mean and not the sample mean, square this, and we divide this by the size of the population in capital N. The reason why in the sample standard deviation we divide by n minus 1 instead of simply dividing by n is to take into account of the fact that S always underestimates sigma, especially, or there's a tendency for S to underestimate sigma, especially so if your sample size is small. So to take into account the potential of our underestimating sigma, we make this adjustment by dividing it by a smaller number instead of a slightly bigger number of n. Okay. Now, to get into the nitty-gritty and to get into the robust mathematical reason behind why we divide by n minus 1, it really is beyond the scope of just a first course in statistics. Okay. But a good intuitive explanation is, again, the reason why we divide by n minus 1 is to take into account the fact that S has a tendency to underestimate sigma. Okay, so make sure you know the difference between a population mean and a sample mean. Okay, they are distinct measures, they are different values, and the distinction between a population standard deviation and a sample standard deviation. And also remember that statistics, x bar and s are your statistics, or any value that is a function of your data. In our case, your data are the heights of the 30 males you have sampled are statistics. Mu and sigma are a function of everybody in your population. Okay, so there really is no data here per se. Okay, and we call this population parameters.